Hi, and welcome to your next lesson in the Waves unit. My name's Mrs. McGee. I'm one of the science directors, and I'm going to be taking you through this lesson where we're going to learn about something called the time period of a wave. Before we start the lesson, remember that it's a good idea to try and avoid distractions, so turn notifications off on your phone or other devices. Now for this lesson, you're going to need a pen and paper or a notebook. If you have access to a computer and a printer, you can also use the Google document that we have created for the lesson. And you are going to need to use a calculator. If you haven't got a scientific calculator at home, then just use the one on your phone, that's fine. So what are we going to learn in today's lesson? In the first part of the lesson, our challenge outcome is to be able to describe what the time period of a wave is. And then in the second part of the lesson, our Aspire outcome is to be able to apply an equation to work out time period or frequency of a wave, and I'll show you how to do both of these. Okay, so let's get started. For our starter then, you have a wave diagram here, and you'll recognize these from previous lessons. Now what I'd like you to do is just quickly sketch this wave. Don't worry about drawing the axes accurately, but I'd like you to just write down everything that you can recall about a wave and see if this diagram helps you. Now you might want to label parts of the waves. You might remember things like crest, amplitude, etc. from previous lessons. You might want to use the numbers on the scale to try and work something out for this wave. So I'm going to give you 30 seconds to do this, just literally anything at all that you can remember. Ready? Off you go. Okay, time's up. Let's see how you did. If you can, grab a different coloured pen and let's go over this together. Now, the top of the wave, remember, is called a peak. You can also call it a crest. The bottom of the wave is a trough. You might have labelled the amplitude, which is the distance from the line of zero disturbance up to the peak. You could also label it from the line of zero disturbance down to the trough. And if you read off the y-axis, you might have spotted that the amplitude here is 3 centimetres. Now you can also label the wavelength, which is the distance between two equivalent adjacent points on the wave. You could also have labelled it between two peaks or between the two troughs. Now again, if you look at the axes, on the x-axis you can see that this wavelength is actually 8 centimetres. The next thing that you might have spotted is that on this diagram, there isn't just one wavelength, there are actually two full wavelengths. So in this diagram, we have got two full wave cycles. And if you look at the top of the diagram, you can see that that is in the space of 1 second. So we've got two waves in 1 second. And if you remember back to the last lesson, this tells you that the frequency of this wave is 2 Hertz, because the frequency is the number of waves per second. So if we've got 2 waves per second, then our frequency is 2 and the unit is Hertz. Before we move on, just pause this video if you need to add any of this information to your diagram. Okay, so we're going to just focus on frequency for a few minutes, just to remind ourselves what we learnt last lesson and how to work out frequency. So frequency is the number of waves in 1 second, and the unit for frequency is Hertz. So in our starter, we had this diagram, and we saw that there were two wavelengths in 1 second. Okay, so we have two waves in 1 second. That means that our frequency must be 2 Hertz. Now, what if instead of 1 second, this actually represented 2 seconds? So in this case, we now have two waves, not in 1 second, but in 2 seconds. So how do we find the frequency? Well, if this is two waves in 2 seconds, we need to work out how many waves in 1 second. So we're going to divide the 2 seconds by 2, to get down to 1. But whatever we do on one side, we have to also do on the other side. So we're going to divide the 2 waves by 2. So that's going to give us 1 wave in 1 second. So now that we know that we have 1 wave in 1 second, we also know that the frequency is 1 hertz. I'd like you to give this a go by yourselves now. So I'm going to show you 3 waves, and I'm going to ask you for each one of them to find the frequency of the wave, and then we will go through the answers together. So here is the first wave, and just looking at the diagram, you can see that there is 1 wave in 3 seconds. There's a bit of a hint. So 1 wave in 3 seconds. So can you now work out how many waves there will be in 1 second? I'm going to give you 30 seconds. Off you go. Okay, let's look at this one together then. So we know that there was 1 wave in 3 seconds, okay? But I want to know how many waves in 1 second. So I'm going to divide the 3 seconds by 3 to get down to 1 second. But whatever I do on one side, I have to also do on the other side. So I'm going to take that 1 wave and divide it by 3. Now you use your calculator for this, and you can find that 1 divided by 3 is 0.33333 recurring. So I've just rounded it down to 0.33. So I've worked out that I have 0.33 waves in 1 second. So that must be my frequency. So my frequency is 0.33 hertz. I'd like you to have a go at this second wave now. Again, find the frequency, and I'm going to give you another 30 seconds. Ready? Go. Okay, let's look at the second one together then. So on this diagram, you can see that there is 1 wave in 20 seconds this time. So 1 full wave cycle in 20 seconds. So I'm going to have to divide that 20 seconds by 20 to get down to 1 second, which means I also need to divide my 1 wave by 20. So in your calculator, you do 1 divided by 20, and that gives you 0.05 waves. So I have 0.05 waves in 1 second, so that's my frequency, 0.05 hertz. So here is your third and final practice for finding frequency. So again, on this wave, can you find the frequency of the wave? 30 seconds, off you go. So let's see how you did on this one. Now this one was a little bit more complicated because there are several wave cycles on this diagram. But let's label the first wave cycle. So if we start at the very beginning and you go to the next equivalent adjacent point on the wave, then here is your first wave cycle. And we do this again, and we find our second full wave cycle, and then we can do it a third time, and we find our third full wave cycle. And we're going to just ignore that little bit at the end of the diagram. So we have here 3 waves, and if you look at your x-axis, that's in the space of 18 seconds. So we have 3 waves in 18 seconds. Now I want to know the number of waves in 1 second, so I'm going to divide my 18 seconds by 18 to get down to 1, which means I also need to divide my 3 waves by 18. So using your calculator, 3 divided by 18 is 0.166666 recurring, so we're just going to round it up to 0.167. So if I have 0.167 waves in 1 second, then my frequency must be 0.167 Hertz. So you should now feel a little bit more confident with what frequency of a wave is. Remember that it's the number of waves in 1 second and it's measured in hertz. So we're now going to look at what the time period of a wave is. So to show you what time period is, we're going to look at those same 3 waves again that we have just worked out frequency for. On this first wave, we can label a full wave cycle. And you can see on the diagram, and we've previously worked out, that this full wave cycle takes 3 seconds. So in 3 seconds, we have 1 wave cycle. That is the time period of this wave. So the time period is how long it takes in seconds for 1 full wave to pass a point. So on this wave, our time period is 3 seconds. We're now going to look at the second wave. And I'd like you to try and find the time period of this wave by yourselves. I'm going to give you a few moments to do that. Okay, let's see how you did. So if we label 1 full wave cycle on this wave, here we go, and you can see by looking at the x-axis that this full wave cycle takes 20 seconds. So that means that the time period for this wave is 20 seconds. Let's look at the third wave now. So again, I'm going to give you a few moments and I'd like you to find on this diagram the time period of this wave. So that is the time for 1 full wave cycle. Have a go. Okay, let's see what it is. So if we label 1 full wave cycle here, I've labeled it between 2 peaks, but you could have labeled it between 2 troughs or between any 2 equivalent adjacent points along the wave. And looking at your x-axis, you can work out, so this wave cycle goes from 1 second up to 7 seconds, so the difference is 6. So the time period for this wave is 6 seconds. So it's as simple as that. Working out time periods is as simple as labeling 1 full wave cycle and just using your time scale on the x-axis to find how long it takes for that 1 full wave cycle to pass a particular point. Okay, time for a quick progress check. In your notes, I would like you to write down the definitions for frequency and time period. Just in your own words, what do these 2 words mean? I'm going to give you 30 seconds to do this. Off you go. Okay, time to grab a different coloured pen and let's see how you did. So the frequency is the number of waves in 1 second. It can also be described as the number of waves that pass a point in 1 second. And remember, it is measured in hertz. And the time period is the time in seconds taken for one wave to pass a point. So how long in seconds does it take for one wave? Okay, so well done for getting through the first part of this lesson. Let's look at our learning outcome again. In the first part of the lesson, we wanted to be able to describe what the time period of a wave is. You should now be able to do that, and you should also be able to work out how to find the time period of a wave from a graph, as well as recall what frequency is. So in the second part of this lesson, we're going to look at the relationship between frequency and time period. Now, if you look at your notes from all the graphs that we've done so far, for the first wave, the frequency that we found was 0.33 recurring hertz, and the time period was 3 seconds. For the second wave, the frequency was 0.05 hertz, and the time period was 20 seconds. And for the third wave, the frequency that we found was 0.166666 recurring, so we rounded it up to 0.167 hertz, and the time period was 6 seconds. Now, if we look at that first one, if you multiply 0.333 recurring by 3, you get 1. I'd like you to give this a go for the other two sets of data. Grab your calculator and multiply them together and see what you get. I'll give you a few moments. Okay, so if you multiply 0.05 by 20, you also get 1. And if you multiply 0.167 or 0.16666 recurring by 6, again you get 1. So this actually tells us something about the relationship between frequency and time period, because every time that we multiplied frequency and time period, we got the number 1. So from this we can extract the general rule that for any given wave, the frequency times the time period equals 1. And we can write that as symbols. So for frequency, we use a lowercase f. For time period, we use a capital T. So F times T equals 1. Okay, so if you look at your physics equation sheet, the one that you get given in the exam, you will see that this equation actually appears here. Period equals 1 divided by frequency. Now it's slightly different to how we have just worked it out. So we have just worked out that frequency times period equals 1. But that is the exact same equation as the one that is given on your equation sheet. It's just rearranged. So now let's look at how we would use this equation in an exam question. In this question, I need to calculate the time period when the frequency is 10 Hertz, and I'm going to show you how to do this. So in this question, we're being asked to work out what the time period is. So that is our unknown. And we're given the frequency. So the frequency is 10 Hertz. Now it's just worth checking that that's the correct unit for frequency, and the unit for our time period is going to be seconds. So the first thing that I'm going to do is write the equation. So T equals 1 divided by F. I'm now going to substitute my numbers in. So I don't know what T is, so I'll just write T again, equals 1 divided by, and my frequency is 10. And I don't need to write the units for frequency. So I'm now going to get my calculator. 1 divided by 10 equals 0.1. So there's my answer. So t equals 0.1, and I add my unit, which is seconds. And there you go. So I'd like you to practice this for yourselves now, and you're going to need your calculator again for this bit. There are 4 more examples here of frequencies, and for each of those, I would like you to work out what the time period of that wave would be. You'll have 2 minutes to do this, but if you need longer, just pause the video. Ready? Off you go. Okay, let's see how you did. Grab a different coloured pen and let's correct these answers together. Okay, so in question A, we're being asked to find the time period. So that's our unknown, and the unit will be seconds. And the frequency that we've been given is 5 Hertz, which is the correct unit for frequency. So we write our equation, time period equals 1 divided by frequency. And let's substitute our numbers in. So time period is our unknown, so we're just going to write t again, equals 1 divided by, and the frequency here is 5. So now we get our calculator, and I'm going to type in 1 divided by 5, and my answer is 0.2. So my period is 0.2, and the unit, which I wrote earlier on, is seconds. So in question B, I need to find time period again. So that's my unknown, and the unit is seconds. This time, my frequency is 0.2 Hertz, which again is the correct unit for frequency. That should be a Z. So I'm going to write my equation, t equals 1 over f. Next, I substitute the numbers in. So t is my unknown, equals 1 divided by 0.2. So get my calculator, and I do 1 divided by 0.2 equals 5. So my time period is 5, and the unit is seconds. In question C, I'm looking for a time period again in seconds, and this time the frequency is 1200 Hertz, but that is still the correct unit. So my equation, t equals 1 over f, let's substitute the numbers in. t equals 1 divided by 1,200. So we get our calculator. 1 divided by 1,200 equals, now you need to be careful here to write the correct number of zeros. So it's 0.00083, and that 3 is recurring, but we wouldn't write that many numbers after the decimal point. Let's stick to 2 significant numbers, so we're going to stop our answer there. Now, do we need to round this up or down? Well, let's look at the digit that follows. It's a 3, so we're going to round the number down, which will give us t equals 0.00083 seconds. Now, the exam question could ask you to convert this into milliseconds because this is quite a small number to leave it as seconds. To convert it into milliseconds, you would multiply this by 1,000. So if I multiply that by 1,000, then I would get a time period of 0.83, and again it's recurring, so we're going to round it, milliseconds. Okay, now let's have a look at the last question, question D. So again, we're looking for time period, and the unit is seconds. But this time, our frequency is 2 kilohertz. Now, kilohertz is not the standard unit for frequency. We need to convert this into hertz. Okay, now an easy one to remember is that the word kilo just means 1,000. So if I have 2 kilohertz, that is the same as saying that I have 2,000 hertz. So I'm not going to use 2 kilohertz in my calculation. I am going to use 2,000 hertz instead. So let's write our equation now. So time period equals 1 divided by frequency. Let's substitute. T equals 1 divided by 2,000. I get my calculator. I do 1 divided by 2,000 equals 0.0005, and the unit is seconds. So just as with the previous calculation, you could be asked to convert this into milliseconds in the exam, and if you did that, you just need to multiply by 1,000. So my time period would be 0.5 milliseconds. We've practiced calculating time period. Let's have a look at calculating frequency. Now you could use this same equation, time period equals 1 divided by frequency, the one that's given to you in the equation sheet. You could use this one to work out frequency as well. But remember that earlier on in the lesson, we worked out that if you multiply frequency and time period, you will always get 1. And these are the same 2 equations, they're just rearranged formats. So to work out frequency, it's much easier if you use this second equation. Frequency times time period equals 1. So now let's look at how we would use this equation to calculate frequency in an exam question. In this question, I need to calculate the frequency when the time period is 4 seconds, and I'm going to show you how to do this. So we're now looking at how to work out frequency when we are given the time period. So in this question, frequency is my unknown. It's what I need to find out. And the unit for frequency, remember, is hertz. The time period given to me in the question is 4 seconds. I will just check, is that the correct unit for time period? Yes, it is. Now I'm going to write my equation. Now you could use the equation that is given to you on the equation sheet, which is t equals 1 divided by f. But if we use this version of the equation, we're going to have to do quite a lot of rearranging because we're trying to find f, but f isn't currently the subject of the equation. So instead of using that version, we're going to use the version that we worked out earlier on, because we worked out, remember, that frequency times time period is always equal to 1. So it's the same equation, we've just rearranged it already. So let's use this version of the equation. So I'm now going to substitute my numbers in. Frequency is my unknown, so I'm going to write f again. And I'm going to multiply it by the time period, which is 4. And that is equals to 1. Now, frequency is what I'm trying to find, so I need that to be the subject of the equation. That means it needs to be by itself on one side of the equation. Currently, frequency is being multiplied by 4, so I'm going to do the inverse of that. And the inverse of multiplying by 4 is dividing by 4. But if I divide by 4 on the left-hand side, I also need to divide by 4 on the right-hand side. Okay, so let's write this out again. So if I have frequency and I multiply it by 4 and then divide it by 4, well, this here, 4 divided by 4, is the same as 1. So it's the same as multiplying frequency by 1, which will just give me frequency. So I write my f equals, and here I've got 1 divided by 4. I'm going to write it as a fraction. So if I get my calculator now, so I'm going to do 1 divided by 4 equals 0.25. So my frequency is 0.25, and just check the unit here, it's hertz. So there is my answer. So again, it's your turn to do some practice. Grab your calculators again. This time I've given you 4 time periods, and for each of these I would like you to work out the frequency of the wave using this equation, f times t equals 1. Again, I'm going to give you 2 minutes, but if you need more time, just pause the video. Ready? Off you go. Okay, how do you think you did with these questions? Grab a different coloured pen again and let's correct these together. So for question A, I'm trying to find frequency. So that is my unknown. And the unit for frequency is hertz. The time period in this question is 23 seconds. And we just check that that is indeed the correct unit for time period. So I'm going to write my equation. So frequency times time period equals 1. I'm now going to substitute the numbers in. So frequency is my unknown times 23 equals 1. Now I need to do a quick rearrange to have frequency by itself as a subject of the equation. Frequency is currently being multiplied by 23, so I need to do the inverse, which is dividing by 23. And I also need to do the same on the right-hand side of the equation, so I'm going to divide 1 by 23 as well. So let's write this again. So 23 divided by 23, well, that's the same as 1. So frequency times 1 is just frequency. And then on the right-hand side, I've got 1 divided by 23. So this is what I'm going to put into my calculator now. So I have my calculator, and I do 1 divided by 23 equals quite a long number. Now we're not going to write all of those digits after the decimal point. We are going to keep two significant numbers. It's usually a good idea in science as a general rule, unless the question obviously tells you specifically how many significant figures to give. So 0.04 is my first significant number, 3 is my second one, so that's where I'm going to stop my number. I just check if I write it out quickly, so 0.0434, but I want to stop it after the 3, so I just check what the following digit is to decide whether I need to round my number up or down. So it's a 4, which is less than 5, so this is going to be rounded down. So my answer is frequency equals 0.043 hertz. Okay, in question B, again, we are looking for frequency. So that is our unknown, and the unit is hertz. And the time period that is given to us here is 0.5 seconds. Is that the correct unit? Yes, it is. So the equation is frequency times time period equals 1. Let's substitute the numbers in. So we don't know frequency, but we do know time period, which is 0.5 equals 1. So I now need to rearrange. So frequency is being multiplied by 0.5. I'm going to do the inverse and divide by 0.5. But I also have to do that on the right-hand side. So I'm going to divide 1 by 0.5. So multiply by 0.5 and then dividing by 0.5. That's the same as just multiplying by 1, so they cancel each other out. So now on the left-hand side, we just have f equals 1 divided by 0.5. So we get our calculator, and I can do 1 divided by 0.5, and the answer that I get is 2. So my answer is frequency equals 2, and I write the unit hertz. Okay, in question C, again, I'm looking for frequency. So that's my unknown, and the unit is hertz. And the time period this time is 0.01 seconds. Is that the correct unit for time period? Yes, it is. So I'll write the equation. Frequency times period equals 1. Let's substitute the numbers in. Frequency times 0.01 equals 1. So now I need to isolate frequency to make it the subject of my equation. It's currently being multiplied by 0.01, so I need to do the inverse, which is dividing by 0.01. And I do the same on the right-hand side, so I'm going to divide 1 by 0.01. So now multiplying by 0.01 and then dividing by 0.01 is the same as just multiplying by 1 because they cancel each other out. So I just have frequency left on the left-hand side equals 1 divided by 0.01. So I get my calculator now, and I can do 1 divided by 0.01 equals 100. So my answer to question C is that the frequency is 100 and the unit is hertz. All right, we're ready for the final question now, question D. Now again, we're looking for frequency. So frequency is our unknown and the unit is hertz. But this time, our time period is 2 minutes. Now check the units. Minutes is not the standard unit for time period. We need time period to be in seconds. So I need to convert 2 minutes into seconds. Now hopefully you remember that in each minute there are 60 seconds. So I'm going to multiply 2 by 60. So my time period is 2 times 60, which is 120 seconds. So this is the number that I'm going to use in my calculation for time period. So now let's look at the equation again. So frequency times time period equals 1. Let's substitute the numbers in. Frequency times 120 equals 1. So now my frequency is being multiplied by 120. I need to do the inverse to isolate frequency. So I'm going to divide by 120. But I also need to do the same on the right-hand side of the equation and divide 1 by 120. So here we go, multiplying by 120 and then dividing by 120 again is the same as just multiplying by 1. They cancel each other out. So I now have frequency by itself on the left-hand side equals 1 divided by 120. And let's use our calculator. So I type in 1 divided by 120 equals, and again a nice long number. So we are going to round it down to 2 significant figures. So 0.0083. The next number would be a 3, so I don't need to round this up, I need to leave it as it is. So 0.0083 and the unit is hertz. So well done for getting to the end of this lesson. Let's review our learning outcomes again. In the first part of the lesson, we learnt how to describe what the time period of a wave is, and we also learnt how to find the time period from graphs. In the second part of the lesson, we learnt how to apply the equation that's given to you in the exam sheet to work out time period and frequency. And remember that you can also use the rearranged version of that equation where frequency times time period equals 1. So now for your final progress check, I'd like you to complete the Google quiz that comes after this video. Remember that, just as with the other quizzes, this will be automatically marked, so you should get your feedback straight away. If there are any issues with this, just message your teacher. Good luck, and we'll see you on the next Waves video.